In the example that I've got shown on the screen over here, we're going to take a look once again to see whether a limit exists. Now, if you take a look at the expression for f of x, you can see that this is a hyperbola, and a hyperbola tends towards two asymptotes. If I want to know that I have a limit, I take a look at this problematic value over here. Can you see that on this vertical asymptote, as I approach it from the left, and if I highlight that once again for you so that you can see, as I approach that from the left, my graph is going to come from the negative x values towards when x is 0. But as I approach it from the right, my graph is going to go from the positive x values back towards 0. Well, you can see that my graph has not reached the same height. If I approach it from negative infinity, my graph is approaching negative infinity for my height. And as I approach my asymptote from the right, my graph is approaching positive infinity from the right. Well, negative infinity is not the same as positive infinity. So it looks very clear that there is no limit in this graph. What would I have done, though, if I tried to work out the limit? Can you see that if I want to work out the limit, I would have said, what is the limit as x tends to 0 for this graph for all over x? You can see, unlike in the previous examples, where I was able to cancel out my problematic denominator, here I cannot. There's absolutely no factorizing that I can do over here. And so my 0 denominator remains. In other words, that means that that limit does not exist. So once again, you can see on this graph that's been drawn for f of x, which is a split function, I might have a problem when x is going to be equal to 2. So if I assess when x is going to be equal to 2, and I draw my finger along the curve from the left towards when x is 2, or from the right towards when x is 2, I have definitely not arrived at the same height. If I had gone from the left, I would have reached a height of 3, and from the right, I would have reached a height of 1. As these heights are not the same, there is no limit in this particular graph. The point f of 2 does exist, and that has been clearly indicated with this point over here. But as the graph from the left and the right do not reach that height of 2, although f of 2 exists, my graph has a discontinuity, and so there is a jump in the way that it tends from the left and the right. Let's just do this so that we could have done it without the picture. If I'd asked whether this limit exists, I would have said, but what is the limit as x tends towards 2 from the left? And I denote that with a little minus above the 2. So coming from the left, I must definitely come from the side where the x values were less than 2. In other words, I must substitute into the portion of the graph represented by x plus 1. If I substitute 2 in here, I'm going to get 2 plus 1, which is 3, which is exactly what we saw was happening. From the left, I reached a height of 3. Now let's take a look, without looking at our diagram. How is my graph tending towards x is equal to 2 from the right-hand side? So that means from the part of the graph that I drew for the x values greater than 2. Well, this portion of the graph is expressed in x minus 1. If I now substitute my 2 in over here, I get a height of 1. And so without even looking at the diagram, I could have seen, because I did not reach the same height, that there is no limit in this particular example when x is going to be 2. There is a limit at all the other x values. My only problematic area was when x was equal to 2.